The planet Jupiter is a world you probably misunderstand. Almost everyone is wrong about Jupiter because our lessons were incomplete. This is not simply a giant ball of swirling gas. Jupiter is fundamentally a planet made almost entirely of liquid. And as if that was not already strange enough for you, the liquid deep inside is actually a very strange metal. Beneath those famous and iconic swirling cloud bands lies a mystery. It is one of the deepest mysteries in our entire solar system. So, let us take a very long and careful dive inside. This photograph is the first close-up image of Jupiter ever taken. It was captured by a NASA spacecraft named Pioneer 11. That historic mission flew past the giant planet in 1974, and this moving picture is the first time-lapse of Jupiter. It was assembled from images taken by Voyager 1-inch 1979. Now, the problem with these beautiful early observations is clear. Beyond looking incredibly cool and scientifically fascinating, they provided few answers. They only raised more profound and difficult questions for scientists. What is this enormous thing truly made of deep inside? And how did it manage to get so impossibly big? The actual immense size of Jupiter is very difficult to grasp. It is not only really big in simple diameter, it is heavier than every other planet combined together. The giant planet takes up enough space for 1,000 Earths. For a more simple and relatable sense of scale here, imagine this. If our planet Earth was only the size of a grape, then the planet Jupiter would be a full basketball. Now, our general theory of solar system formation is simple. It starts with a big disk of dust and gas. This disk contained rock and metal and other stuff spinning. All of it spun around the newly formed and young sun. Then over many millions of long and slow years, stuff collided. All the material in that disk kept violently smashing together. These collisions formed increasingly larger chunks of rocky material, and then, as those chunks grew even bigger, gravity activated. Their stronger gravity started to attract even more loose stuff. So under that sensible and logical early formation theory, Jupiter formed. It happened when one chunk grew large enough for gravity. Its gravity started capturing massive amounts of swirling hydrogen gas. It just kept doing that for billions of years continuously. It grew until it became the giant we see today. That straightforward story makes perfect logical sense on the surface. If true, it would mean Jupiter has a dense, solid core. This core would be very big and made of metal. An alternative fun theory is that Jupiter started differently. It may have begun as a separate gigantic gas cloud. This cloud was sitting just outside the early solar system. Over immense time, that cloud grew massive under its own gravity. It eventually collapsed into a dense and hot ball. This process is pretty much the same way a star forms, only stars need a much bigger starting cloud of material. So in this specific planetary case, you get a big planet. Eventually, that new planet got pulled by the sun's strong gravity. It then settled down into a stable and permanent orbit. If this particular wild theory were actually completely true, then Jupiter would not really have any solid core at all. It would just resemble a big layered cake of gas. But the theory most people learned involved a big solid core. That solid core captured all of the surrounding light gas. And again, that classic story does make a lot of sense. It is not a totally crazy thing for anyone to believe. However, it is also not entirely scientifically correct anymore. Our first real breakthrough in understanding Jupiter came much later. It happened in the scientific middle of the 1990 decade. And this is one of those insane cosmic coincidences ever. It honestly sounds almost too good to be genuinely true. But in July of 1995, the planet was hit. It was struck by a very large and famous comet. This kind of direct collision is not a common event. Scientists estimate a collision like this happens once every 6,000 years, but we humans were fortunately around to see this one, and we had the advanced technology to watch it happen. This comet was named Shoemaker-Levy 9 officially. It was a big chunk of frozen ice and rock. It was hurtling through our solar system at incredible speed. It is very hard to say how big the comet was. By the time we found it, Jupiter's gravity had acted. The powerful gravity had already fractured the object into pieces. The largest of those mini pieces was still 2 kilometers across. And at this exact point in astronomical time, NASA was ready. They had their newly operational Hubble telescope prepared to observe. But there was one very big and obvious problem. The comet pieces would hit Jupiter on its far side. That impact site would be out of view from Earth. We were going to completely miss the entire historic event. Except at the exact same time, NASA had a spacecraft. It just also happened to be arriving at Jupiter right then. This spacecraft was called Galileo, named for the famous astronomer. Galileo was the first to study the planet through a telescope. The probe was originally launched back in 1989. Its mission was to investigate Jupiter and its many large moons. It was scheduled to finally arrive in December of 1995. Now it had a perfectly clear view of the comet impact. What the probe saw was 21 separate collisions. These impacts occurred over the frantic course of 6 long days. The largest chunk of comet unleashed unimaginable energy. It was the equivalent of 300 million atomic bombs. That made it the biggest explosion ever caught on camera. As the giant planet slowly rotated its damaged face around, the Hubble telescope was finally able to see the aftermath. Those strikes actually left behind big black holes in the clouds. They also kicked up massive towering plumes of hot debris. These plumes were thousands of kilometers high above the clouds. They lingered visibly above Jupiter for many long months afterward, and this is the environment the Galileo spacecraft finally arrived into. The hidden insides of Jupiter had been kicked out into space. The tough little probe was able to fly right through them. This was our very first direct look underneath the cloud layer. People had been staring at those clouds in wonder for centuries. The most interesting thing Galileo found was actually simple water. It discovered a lot more water than anyone had predicted, and scientists immediately thought that finding was pretty weird. It was weird enough to start planning another mission to Jupiter. They designed a new probe for one specific purpose. It would seek out the planet's true and mysterious nature. That important mission was officially named Juno by NASA. The Juno spacecraft was successfully launched in the year 2011. It finally arrived at its destination in the year 2016. It began immediately solving the mystery of Jupiter's fuzzy core. So when we say your school lessons were wrong, we mean it. We did not even start learning the real truth until recently. So here is what your science teacher did not know then. Jupiter is not simply made of light gas. It is covered in big, thick clouds of gas, certainly. Those clouds form all of those iconic swirling rings and storms. But those clouds are just a thin decorative top layer. Below them lie much stranger and more extreme things. But let us start logically from the very atmospheric top. In the high clouds of Jupiter, the temperature is far below freezing. It is consistently colder than -100 degrees Celsius. Water ice crystals interact with ammonia there in the clouds. Ammonia acts as a powerful natural antifreeze in this environment. This allows liquid water to exist in the upper cloud layer. As droplets collide violently with ice crystals, the clouds electrify. This process triggers gigantic planet-wide lightning storms that constantly rage. This super chilled water and ammonia mixture eventually clings together. It forms slushy hailstones that fall into the lower atmosphere. There they melt into rain, evaporate, and then rise again. These powerful jets of hot gas rise up constantly. They fuel the raging and endless storms on the visible surface. These jets reach incredibly deep down into the planet's atmosphere. This dynamic process is what we see in the Great Red Spot. Not only is it thousands of kilometers in total diameter, it also extends down hundreds of kilometers into ammonia rain. The red spot reaches up higher than other Jupiter clouds. It extends far above the general surface cloud level. It therefore absorbs more dangerous UV light from the sun. That light reacts with chemical compounds inside the giant storm. This complex reaction creates that distinctive and deep red color. Now try to imagine a cloud 10 times taller than Everest. Also imagine it being 10 times deeper than our ocean. That immense scale still would not capture the red spot. As spectacular as this outer cloud layer might appear visually, the average depth of these clouds is only 50 kilometers. As we descend below the clouds into lower atmosphere, the temperature begins to rise dramatically and consistently. This intense heat is caused primarily by immense pressure. When you compress molecules, you concentrate all of their energy, and the extreme pressure is created by Jupiter's fierce gravity. The incredible mass of the planet itself pulls material down. It squeezes everything tighter and tighter as you go deeper. Some truly weird physical stuff begins to happen down there. The further down we go into the gravity well, the more the heat and pressure build up exponentially together. It is like traveling through an increasingly thick fog. The fog becomes thicker until it finally becomes a liquid. Except here, the fog is not made of water. It is made almost entirely of simple hydrogen gas. Hydrogen is the very lightest element in the entire universe. And in an extreme gravity environment like inside Jupiter, it is the only thing that can possibly stay afloat. All of the heavier elements sank down long ago. They were pulled down forcefully into the planet's deep core. At a depth of 1,000 kilometers below the clouds, the hydrogen gas completes its major phase transition. It becomes a strange and vast liquid state, and this is the closest we get to any surface. It is a global ocean of liquid hydrogen molecules. This is undoubtedly the largest ocean in our solar system. So, while the giant planet is covered by a gas shell, it is definitely not made of gas fundamentally. It is truly and utterly a liquid planet. But this is a far stranger liquid than anything else. On Earth, we can liquefy hydrogen by making it very cold. Our atmospheric pressure lowers hydrogen's boiling point dramatically. But on Jupiter, the complete opposite effect is happening. The intense internal pressure raises the boiling point extremely high, so hydrogen can exist as a liquid at over 1,000 degrees. This planetary ocean is about 20,000 kilometers deep. That is 2,000 times deeper than Earth's entire ocean. And as we reach the very bottom of this ocean, the pressure and temperature have a very bizarre physical effect. Under millions of times the pressure of Earth's surface, at temperatures nearing 10,000 degrees Celsius, hydrogen changes. It changes state into something called metallic hydrogen. Now, that term does not mean it turns solid. It is still very much a hot liquid inside. But it is now a conductive metallic liquid. Maybe something like the mercury inside an old thermometer. The biggest physical change here involves electrical conductivity. Metallic hydrogen now has the ability to conduct electricity. Jupiter's gravity squeezes so tightly that electrons break free. They flow freely throughout the hot liquid metallic hydrogen. This flow generates a powerful planetary electric current. This liquid metallic hydrogen makes up the planet's majority interior. It is about 40,000 kilometers deep in total. And down there at the very bottom of everything lies the core. We previously believed in a compact and dense core object. It was thought to be about the size of Earth. It would be made mostly of dense iron and rock. That sensible idea made perfect logical sense for years. But new Juno research is uncovering a much fuzzier core. The transition between liquid metal and solid core is blurred, meaning the two distinct layers kind of mix together. The fuzzy core spans about half the planet's radius. Scientists now believe it is like a dense soup. It is a mix of liquid, rock, and stirred metal. There is no clear boundary between states of matter. Now, we are not sure if this is unique. It might be a characteristic unique only to Jupiter. We have not studied Saturn nearly enough for comparison. We are not sure about its internal situation. Therefore, this fuzzy core could be totally normal for giants. It is thought that if Jupiter's core is unusual, a massive collision in the early solar system occurred. There might have been a rocky planet 10 times Earth's size. It was floating around until it slammed into young Jupiter. The energy from that would have scattered the solid core. This might also help explain how Jupiter grew so big. The giant collision theory makes a lot of sense, but that does not necessarily mean that it is true. Recently, astronomers decided to recreate this event via simulation. They ran countless impact scenarios with different planetary sizes. They simulated planets smashing into a young Jupiter repeatedly. At first, they saw the expected fuzzy core result, but in every single simulation they carefully ran, the fuzzy core would relatively quickly settle back down. It would solidify into a clearly defined central ball. So, we know Jupiter has this big, weird, fuzzy core, but we honestly do not know how it got there. For all that we have learned recently from Juno, we really have no clear answer on planetary formation. How does a planet like this even get created? And that profound mystery is what makes Jupiter so cool. It is just fundamentally weird in every single way. It is a giant mystery floating in our sky. It is a mystery that constantly begs to be solved. And we will most certainly get there eventually. Until then, keep looking up because the universe always has more secrets to reveal.